Hey folks, this lesson is scientific notation with negative powers of 10. In the last lesson we did positive powers of 10, all numbers that were big numbers. These are going to be small numbers, all numbers that are less than 1. So same Common Core strand for our teachers here. And then how can we use scientific notation to express very small numbers? Okay, so something like a 0.0000521, that would be, and we can convert that to scientific notation. All right, remember you guys, scientific notation is written in this form where this number is somewhere between 1 and 10, so it could be, in fact, most of the time it is a decimal. So like 1.015, that's a number that's greater than or equal to 1 but less than 10. And then this number is any integer, okay? And if our number is very small, then n is a negative integer. And if our number is really big, then n is a very big number right there, okay? So, it's useful in dealing with very large numbers. The last lesson that we did, or very small numbers. That's this lesson. Okay, so writing a number in scientific notation. So to write a number greater than 10 in scientific notation, we moved the decimal point to the left, and then that made positive exponents with 10. That was our last lesson. So something like this, you guys. So 84,000. So here's 84,000. We want this number to be somehow represented between 1 and 10, so we're going to make it 8.4. So what we did is we moved that decimal place back in this direction 4 spots right there. So 8.4 times 10 to the fourth, okay? And then when we're dealing with numbers that are less than 1, then we move the decimal point to the right to write it in scientific notation. And that's this lesson, okay? So here's a number, 0.0783. So we're going to make it and put the decimal right there, 7.83. So it went 2 spots. So it went to the right, so it's negative 2 right there. Remember, these numbers have to be somewhere between 1 and 10. It could be 1, but it can't be 10. If it's 10, we've got to move the decimal place one place over. So the average size of an atom is about all those zeros. Let's count them up here. So let's see. So 1, 2, 3, 4, 5, 6, 7 zeros, and then the 3. Okay, so we want to move this decimal way over here in front of the 3. Okay, so it's 3, which is greater than 1, less than 10. So write that there. So what we're going to do is move it over. So here's 1, 2, 3, 4, 5, 6, 7. Got to do one more. 8. So it's 3.0. Typically they carry it to the 10th spot. That's why we wrote 3.0 times 10 to the negative 8, because we had to move it 8 places to the right. All right, now I didn't like questions 1 and 2. I just didn't think they fit very well, so I skipped them. So here's question 3. So when we write a number that is less than 1 in scientific notation, how does the power of 10 differ from when we write a number greater than 1? Well, remember, when it's less than 1, then the exponent with 10 is going to be a negative number instead of a positive. And they're integers too, so they're counting numbers. So let's write these numbers in scientific notation. Okay, so I'm going to move this decimal right here between the 8 and the 2, so it becomes 8.29. So here's 1, 2, 3, 4, 4, 5. Whoops, I did 2 of them right there. Sorry, I did 2 of them. Yeah, I sure did. I did 2 of them, so 4, 5. Sorry about that. Let's just count them real quick. So here's 1, 2, 3, 4, 5. So it's going to be 8.29 times 10 to the negative 5. Okay. So this next one, I'm just going to jump them all over there right there and just count the humps right here. So here's 1, 2, 3, 4, 5, 6, 7. So it's 3.02 times 10 to the negative 7. All right, a typical red blood cell in a human blood has a diameter of approximately 0.000007 meter. Now, meters it's a little bit longer than a yardstick. I don't know why they're measuring that in a meter, but they want us to do scientific notation. That's why. So write this diameter in scientific notation. So we're going to move it to the right. How many places? So let's see. I want it to be at that 7 right there. So you can hear a crow flying by. 1, 2, 3, 4, 5, 6. So 7.0 times 10 to the negative 6 right there. Okay, easy, right? All right, so to translate between scientific notation and standard form, so they're going to give it to us in scientific notation and they want us to put it in standard form. So with very small numbers, we can move that decimal point to the number of places indicated by the exponent of the power of 10. So when the exponent is positive, in the last lesson, we move that decimal to the right. And when it's negative, that's what this lesson is, then we move that decimal back to the left. Okay, so here's an example. Platelets are a component of the human blood. A typical platelet has a diameter of approximately 2.33 times 10 to the negative 6 meters. Write this in standard form. So here's 2.33, and so we're going to go, since it's negative, in the last lesson this was positive, and we would put it to the right, make it a big number, but when it's negative it becomes a very small number, so that means we're going to the left 6 places. Okay, so here we go. So here's 1, 2, 3, 4, 5, 6. Okay, there's the decimal right there, and then fill in all those blank spots with zeros. So this equals 0.0000213 meters. Okay, all right, easy, right? Okay, so explain if 0.9 times 10 to the negative 5 is written in scientific notation. If not, write the number correctly in scientific notation. Well, it almost is, you guys, except that's not greater than 1. 0.9 is not greater than 1. We want it to be 9, so we have to move that decimal. So no, it's not in scientific notation. Remember, that first number must be greater than or equal to 1. So with 0.9, then the decimal must move to the right to make it 9.0, and the exponent is going to decrease by 1. Now careful, it's negatives, you guys. So when I decrease this exponent by 1, negative 5 minus 1 is going to take me to negative 6. Okay, so it becomes 9.0, or 9 times 10 to the negative 6. Okay, which number is larger, 2 times 10 to the negative 3 or 3 times 10 to the negative 2? And explain. All right, well, I like to do this, you guys. I like to put them in standard form. 2 times 10 to the negative 3 means move the decimal from here 3 places that way, so it becomes 0.002. 3 times 10 to the negative 2 says move that decimal 2 places that way, so it becomes 0.03. So 0.002 is less than 0.03. So this value is 3 times 10 to the negative 2 is larger because the exponent is greater. Negative 2 is greater than negative 3. Okay, so remember, negatives work kind of backwards, you guys. Negative 2 is bigger than negative 3. Okay, all right. So write these numbers in standard form. Okay, so remember, if it's negative, I'm going to take that and move it to the left 6 places. So here we go. I'll move that to the left 6 places. Okay, so there it is, 1, 2, 3, 4, 5, 6, and then put the zeros in there so it equals that. Same with the 9.9, so 9.9, 1, 2, 3, 4, 5, put the zeros in, and so it equals that. Jerry measures the length of an ant as 1 times 10 to the negative 2 meters. Write this in standard form. So we're going to take that 1, which is 1.0, and move it 2 places to the left. Okay, put the zeros in, and so it equals 0.01 meters. Okay, all right, you guys, I hope that makes sense, and take care.